Simon Moncrief. Simon is working as part of a team who are designing new architectures for web mapping. This has come about as a result of a demonstrator in Western Australia, which, although successful for the West Australian Department of Health, it did also highlight some limitations in web mapping that Simon and the team are working on. This project has 543PL companies as members. That's Insight GIS, Esri Australia, Critchlow here in New Zealand, SKM and Spatial Vision. And the government department in Western Australia, the Government Department of Health, is also very active in the project. So as we move more to try and transfer some of this knowledge and transfer the system into a more sustainable business model, these partners will form a critical part of the team, and it's an interesting time ahead. So over to you, Simon.
So I'm Simon Moncrief from Curtin University in Western Australia. So I'm not sure what the title of my talk is in the thing, but I'm basically talking about geovisualization and health GIS using a web service approach. So what do I mean by that? Well, the motivation behind P441 was geovisualization and health. So essentially, we're combining three concepts: health GIS, visual data mining, and web GIS. So health GIS is looking at spatial distributions of diseases, and that also includes the temporal, and also external factors such as socioeconomic, environmental. Visual data mining, so using information visualization, which is the process of summarizing large data sets to derive, visual summaries of large data sets to derive meaning from them in the spatial context. This is called geovisual analytics. And WebGIS covers quite a large gamut, but I'm more interested in the web service aspect. So it does include things like usability, but I'm more focusing on data access, and by data access that also includes access to interfaces and visualizations, not necessarily the design of the interface. So simplest example of this is a thematic choropleth, or thematic map choropleth, and Slippy web map client. So thematic web maps, the aim is to visually summarize spatial data, and the process of generating them is to have an analysis result, so process some data, get the results, and then render the data layer using a classification technique and in conjunction with a color scheme. So generally, or traditionally, this is done using, say, a WMS service, so that's an OGC compliant web map server. You store the map layer in, say, a shapefile or PostGIS table, and then that gets, when you render it, it gets an XML file dictating the star rules is applied, and you produce the map. So this leads us to the question, health, how many layers do we generate? So with the morbidity data, which is what I've been focusing on currently, you have 14,000 ICD-10 disease codes. You have an age range you can choose, a gender, time interval, and also spatial resolution. So the ABS has SA234 in a hierarchy, where SA4 is the lower resolution, going down in the hierarchy to SA2. We have SA1, but we don't have population for that, so we concentrate on SA2 and above. But essentially, all this will produce, you do a query on any of these, and you produce a subset. You can then process that to generate the map layer. To provide full flexibility for researchers, to provide flexibility, we can't predict what researchers are actually going to want. So how do we generate, so which layers do we generate? And the other problem is, so you have that many choices for each one. So 14,000 disease codes, age ranges is a few, and so on. So for 10 years of data, you can produce potentially 1 billion map layers. For 11 years of data, you've got 1 trillion. One issue with that is, again, with the flexibility, a lot of those layers will be empty. So, yeah, how do you solve that? Well, general answer is to potentially generate all the trillion map layers, but by using a user pull rather than a supplier push approach. So in this one, we're using query-driven dynamic web mapping. So the layer is generated on the fly when the user requests it. The data is dynamically aggregated, so it can be either unit record or point record data. And then it's done in an interactive yet automated way. So the data is stored in a database. A query is run over it, specified by the user, and then a process also specified by the user is then applied to the subset. and this is run through a privacy and reliability filter, which is an important part of this project, because if you're giving access to essentially millions of unit record data, you do need privacy in the way. And that will generate the layer. So using this one, we can potentially generate any layer, just the privacy and reliability also help making sure the layers are useful. And then the styling can also be done. So if you notice also it's all done on the server, and then the client just use the output of the either vector or map data. So just quickly, this is talking about the empty map layers. So I've got a year's worth of synthetic data, so it's about 800,000 unit records. And I ran the query over major code. So this is actually aggregating the entire population by SA2s for each major code in the data set. So the y-axis is the number of SA2 regions which return a result. And so the x-axis is just the query stack. So the green line at the top shows the actual number of SA2s which return a result. The red line is the default privacy policy applied in the health department currently, so that's how many you would get at the moment. And then the blue line is just using dynamic privacy to not suppress data which you may not need to. So the difference between the red and the blue is sort of information which can be released which currently isn't. The other thing with information visualization, the data is stored as data, so from that we can produce multiple results. And for each result, we can also do multiple visualizations, and of course we can tie together visualizations and present them simultaneously. So this one actually runs a bit slow, so I might skip parts of it. So essentially this is an example of a visualization which can be generated on the fly. The y-axis in this case is the population density of school-aged children, and the x-axis is the median income. The colors are done according to SA4 region, and the time is going, well, as they move very, very slowly. So, and it's going to be freezing. So essentially, it's an interactive graph, and what it will show eventually, when it stops freezing, the two red zones I clicked on, one of them is Canning Vale. If you live in Western Australia, that might mean something. The other one, I forget. But essentially what this shows is the population density of school-aged children is increasing over the 11 years, so over 3 census years. And then, okay, so this one was, I think, Thornley. So that's an old mortgage belt. Canning Vale is a new mortgage belt, and it's not showing anything you wouldn't be able to guess, I guess. But it's just an interesting way to visualize the information. So the red ones move up rapidly or not. Well, okay. I'll be out there, so if anyone wants to see this, let me know. Hey, there we go. Something happened. And the bottom red one there is Perth. So Perth essentially, and I can show you if you want. Perth just goes statically across. Canning Vale and the other one move up, and then so Kingsley and Thornley both move down. So you have the old mortgage belt moving down, the new mortgage belt's moving up, and the city just staying like that. And the population, interesting for Thornley, doesn't really decrease very much, so I guess the kids stay at home. So this is the prototype system that I use. It's an agent-based modular approach. So each data set, the morbidity, demographic, socioeconomic data sets, they're each handled by a data agent, and then there's a MapServe SDI which sort of orchestrates communication between them. And then there's a few other ways to generate sort of visualizations, advanced visualizations. But there's also user interface generation. If it helps, think of that as a sort of dynamic process, almost like a WPS, but less metadata. Yeah, so the other thing I should mention is it follows semantic web constructs, so it's heavily reliant on metadata. And of course, again, you see everything happens server-side with the user interface just consuming on client-side. So this, again, usability issue. Interesting part. So using a software agent data management approach is actually quite interesting because the agent handles the logic between the data and the users. So the data access is completely abstracted from the user of the web client. So for example, you could be accessing 10 million unit records, or you could be accessing OGC WFS service or an Esri REST endpoint. It doesn't matter. The agent handles that one. But and also, for example, a spatial model could be just presented as a virtual data set. They wouldn't need to know the model. They just click and get the result. But what this also lets us do is present what I'm calling possibly either virtual or meta attributes. So we can present different users with different attributes to query in the system. So for policymakers and epidemiologists, they're really only interested in by year or by financial year or calendar year. So we can show them the interface, select the year, and then do you want calendar or financial? It goes to the agent knows what financial year is, so it then inserts the query and does the query in the database. So we can sort of do that, but completely abstract the concept from or the actual date SQL querying from the user. And so we can also, for the same data set, present researchers with access to the actual date range. So it could be a date range, or it could be a date range over a year, or then if you really want to do some interesting stuff, you could do summer, winter, that sort of thing, or weekend, weekday. And also the agent-based paradigm can extend to non-health data. Okay, this is getting interesting. So using this approach, also spatial resolution is a parameter, temporal resolution is a parameter. So doing queries using a for loop is actually really easy to generate motion maps by incrementing over a year or okay, I'm going to skip some of these ones. Again, we'll be up there. So distributed data workflows. Basically, this work represents an automated workflow for health through linking of agents. So this actually raises a number of issues related to, because it's a distributed data workflow, you have data versioning, you need rollback because it can be used for policy, feed forward, it can be used for update and surveillance. So because it's an automated workflow, if the data changes back in the chain, it can be fed forward, and also a transformation generates a new linkage, a new data set. So age standardized rate is an example of a workflow. So it incorporates a morbidity data subset, demographics as a population, and a standard population for the smoothing. You can link them and maybe reach a decision about something. But the standard population in the Department of Health is apparently 2001. So eventually it'll move to 2011. They do it by 10-year increments. So when you update the population, the standard population, you might actually come up with a different age standardized rate. The same token, the ABS, so the population between ABS census years is an estimate. So when you get the new census, you have to roll back and change the population. So again, you might need to rethink the decision, and again, that can be automated. Other thing I'd like to mention is metadata. So each link in the chain of the workflow introduces a new set of data, which, if everything's going to be orchestrated properly, needs to be accounted for. Other thing I'd really like to mention quickly is the data storage philosophy. Now, this is a major kind of hurdle in the linkage and orchestration of spatial data, given the shapefile layer paradigm that's often used. So if you think of data in a thematic layer, the time element is actually in the layer name. You think of the WFS data can sometimes be in the column name, but ideally time should be a column. So you should be able to access the data just using, so access the temporal element just using a query rather than looking at the map layer name sort of thing. So again, issues that we still have to look at is usability and user interface design. Again, workflow automation integration, given that one. So provenance, feedback, feed forward. Standards, so OGC has just started up a health domain working group to figure out the standards, and again, extension to privacy and visualization. Nope, okay.